Let's continue with this lecture series, and this is our fourth lecture on kinematics. Let's see our next question. Our next question says, a small block slides down on a smooth inclined plane. So let me first draw an inclined plane. Let's say this is an inclined plane and this is a smooth inclined plane. Smooth inclined plane means no friction here, right? And we have a block over here and this is sliding down, right? Okay, great. Starting from rest as per the question. So initial velocity u is nothing but 0 at t equal to 0. So this is initial time. Let Sn be the distance traveled by the block in the interval Tn minus 1 to Tn. Fine. Then the ratio of distance traveled Sn and Sn plus 1, right? So what we will do here is, we already know what is the acceleration due to gravity in case of an inclined plane, right? That we have done in case of laws of motion, but now we will not make use of that. We can solve it using simple kinematics equations. And what is that? Our equation says Sn, distance traveled in nth second, that is nothing but u plus a by 2 into 2n minus 1, right? This is our relation, if you remember, correct? So we will make use of this relation in this particular problem to figure out our ratio of Sn and Sn plus 1. So first of all, to find Sn, our initial velocity as per the problem is 0. So Sn will be nothing but a. Okay, so I'm just keeping it as a only. We are not putting that g sine theta minus mu g cos theta, that g cos theta. Okay, that we will see later on in our means the laws of motion. Right now we don't require it, so we'll straight away keep it as a by 2 into 2n minus 1, right? So n is n only, so 2n minus 1. This will be our first equation. This is our Sn, right? Now what we have to figure out? Now we have to find Sn plus 1. So our Sn plus 1, that would be, again u is 0. A will be still the acceleration, the same acceleration while coming down, okay? And since it's a smooth surface, here the friction will be also 0, okay? So here this will be 2 into, what will be our n plus 1? N will be n plus 1, right? In this case, minus 1. I hope this is clear, right? Now what we will do? Now we will divide both of them to get the ratio. So Sn divided by Sn plus 1, okay? That would be nothing but a by 2 gets cancelled and you left with 2n minus 1 on the top here, and here when you open it will be 2n and plus 2 minus 1, which is plus 1. So correct option here is option B. I hope this is clear. This is 2n minus 1 whole divided by 2n plus 1. Clear it is? Okay. Let's see our next question in this series. Our next problem in the series is this one. Okay, let me read it for you. A person sitting in the ground floor of a building notices through the window of a height 1.5 meter, fine, a ball dropped from the roof of the building crosses the window in 0.1 second. So distance traveled by the ball is nothing but 1.5 meter. And how much time it has taken? It has taken 0.1 second, right? So let's assume that this is our window, and if it is of the size 1.5, I am sitting here and I am observing at this ball. The ball is falling down, right? Okay. Yes. Fine. So if a ball is falling down like this, okay, and it is going from here to here, right? If it is going from this point, any point A to point B, this distance here is nothing but 1.5 meter, and the time taken by this ball to go from A to B is 0.1 second as per the question. Clear? Now the question says, what is the velocity of the ball when it was at the topmost point of the window, which is at this point? We have to find what was its velocity, and the question is saying take g, acceleration due to gravity, at 10 meter per second square, right? So we have to figure out when the ball started its motion at this point, what was its velocity. So basically we are looking for initial velocity, right? So s will be equals to ut plus half at square, right? I hope this is clear. Now s is nothing but 1.5. What is our initial velocity while going down? Sir, we are looking for that. What is the value of t? T is 0.1, so 0.1 here, plus half. And what is g? Acceleration due to gravity is 10, and t square, which is 0.1 square. I hope this is clear. Clear? So when you are going down, okay, this will be your equation, and here it will be 1.5. Clear? That will be equals to u into 0.1 u plus, now taking 2 and 5, this will cancel out 5, 0.01. I hope this is clear. Clear? Now this will be 1.5 equals to 0.1 u plus 0.05. I hope this is clear. Now let's take this 0.05 on the other side. It will be 1.5 minus 0.05 whole divided by 0.1. That's our u. Correct? So 1.5 minus 0.05. Let's simplify. 10 minus 5 is 504, correct? And 0.45 whole divided by 0.1, that's our u. Okay. And removing this, you will get 100 here down. Removing that 10, you will get 4.5 meter per second. That's our initial velocity at this point, at the topmost point. Option C is the correct one, right? So 4.5 meter per second, we got this as our answer. I hope this is clear. Clear? Okay, let's see the next one in the series. Our next question in the series is this one. Let's read this question. A ball is thrown vertically downward with a velocity 20 meter per second. So be very careful. You are throwing the ball downward. It's not zero. It's not freely falling, right? So you are throwing a ball downward with a velocity 20 meter per second. So initial velocity u is 20 meter per second. Great. From the top of a tower, it hits the ground after some time with a velocity of, final velocity here is 80 meter per second. I hope this is clear. 80 meter per second. The height of the tower is how much? Okay, that you have to calculate. Now we know that if you are throwing something from a building or a tower, okay, here it is v, here it is u. The distance it has traveled is s. So we'll make use of equation of motion. V square minus u square equals to 2as. I hope this is clear. Now v square, that's 80 square minus u square, which is 20 square, and that will be equals to 2 into, I am assuming, acceleration due to gravity, and as per the question it is saying 10 into s. 80 square 6400, 20 square 400, whole divided by 2 into 10, I am taking on the left hand side, it will be 20. Now 6400 minus 400, that's 6000, right? Whole divided by 20, that is equals to distance s, and that will give us 300 meters. That's our distance traveled by this object. Clear it is? Or the ball. So ball is traveling how much? 300 meters. That's option C. I hope this is clear. Let's see the next one. Great. We have another problem. The another problem is conceptual problem, and we have to understand the core concept here. A person standing on the floor of an elevator. Elevator, in case if you are not familiar with elevator is nothing but a lift, right? So if it's a lift, okay, and drops a coin, okay. Let me read it for you again. A person is standing on the floor of an elevator, drops a coin. So simply assume that I am standing on a lift and I have a coin and I am dropping it. When I am dropping it, I am not throwing it with some velocity. Initial velocity is 0. So I am simply dropping it. Okay. The coin reaches the floor in the time t1 if the elevator is at rest. Assume that I am standing on an elevator or I am standing on a lift. I am releasing a coin. The coin is falling down and it takes time t1 to reach the ground, right? And in time t2, if the elevator is moving uniformly. Now, this is the crucial point here, moving uniformly. Okay. So many students, they do this basic, they go wrong here. Okay. What is the problem with this part? Moving uniformly. So if it is moving uniformly, which means it moves with a constant velocity. And if something which is moving with a constant velocity, what will be the acceleration? So the acceleration will be 0. Let me repeat again. If the velocity is constant, the first derivative of this will be 0, because constant derivative is 0. It's not changing with time. It's a constant. So dv by dt is 0, which means the acceleration of this elevator is 0. This you have to be very careful with. This small word will change the whole scenario. Clear? Sir, what if there was no such word in this particular problem? If there was no moving uniformly, if it was same, but if without this moving uniformly, then the answer will be different, right? So since it is moving uniformly, the velocity is constant and the acceleration becomes constant, and because of this, let's see what will be the outcome. The question says, then which of the following option is correct? In case if there was no moving uniformly, then we would have done option A. We would have done the time taken will be different in different case. When the elevator is stationary and when it is moving upward, there will be a acceleration. The relative acceleration will change the mass, the weight, and then the things will change, right? Okay. So here, since the velocity is constant, dv by dt is constant, acceleration is 0. Since the acceleration is 0, it's the same condition when you are taking it, okay, and releasing it. The time taken will be equal in both the cases. Clear it is? Because there is no relative same inertial frame of reference. I hope you are familiar with this word, inertial frame of reference. If you are not familiar with inertial frame of reference, fine. Just assume that if the acceleration is 0 on such a system, in that case, the time taken will be equal. Great. Conceptual problem. Let's move to the next one. Great. We have done one more problem of this kind in the previous lecture. So if you have not watched this, I have placed the link in description. You can watch it. Okay. Let's come back to the problem. Question says a stone falls freely under gravity. It covers distance h1, h2, and h3 in the first 5 seconds, next 5 seconds, and the next 5 seconds. The relation between h1, h2, and h3 is how much? Okay. Now without solving, we know already this is our answer. I have given you in the previous lectures that how we came up to this, right? Let me solve it for you in case if you don't remember, or in case if you have directly jumped to this particular video, okay, all of a sudden, then let's see how we get this. Okay, so question says here the relation between h1, h2, and h3. Okay, let me come back to the problem. The problem says, let's say you are releasing an object. Okay, the object is stone. A stone is falling freely under the gravity. So what's its initial velocity here? 0. And it is going from A to B in what time? Sir, it is going in 5 seconds. Fine. Now B to C, it is going in, sir, again 5 seconds. And C to D, again 5 seconds. I hope this is clear. Okay, by now the things are clear. A stone is released from any point A. It is going from A to B in 5 seconds, B to C in 5 seconds, and C to D in 5 seconds. Each 5 seconds, it is traveling this much. We don't know how much it is. We will find it, figure it out, right? Let us assume that from A to B, the height is h1. B to C height is h2. C to D height is h3. We have to find a relation between h1, h2, and h3. Clear? Okay. Be very careful. The height from A to C is h1 plus h2. Height from B to D is h2 plus h3, or A to D is h1 plus h2 plus h3. Clear? So let's start solving this problem and first figure out the value of AB. So AB is h1, that will be ut plus, so I'm writing here the equation. I'm using this equation S equals to ut plus half at square. I'm using this particular equation. U is already 0 in this case. Half g, acceleration due to gravity, and what's the time? Sir, 5 square. I'm just placing it 5 square. If something is getting cancelled, I'll cancel it later on, right? This is our time. Okay, I hope this is clear. Now, if I'm going from B to C, be very careful. If you are finding the height, the distance from B to C, you should know what is the initial velocity at point B. In case if you don't know what is the initial velocity at point B, first figure it out. This is one way. Or you can say that we can find A to C and then subtract AB, correct? So I am finding A to C. A to C is how much? h1 plus h2. So distance will be h1 plus h2, and that will be for this particular height h1 to h2. What is the initial velocity? Sir, it's 0. In that case, half. And what is the time here? Sir, 5 seconds plus 5 seconds. It's 10 seconds whole square. Be very careful. On the left hand side, it should be h1 plus h2 and not h2, because you are not finding B to C, you are finding A to C. Sir, why can't we find B to C directly? In that case, you need the initial velocity at B. If you are using this equation, you will not be 0 from B to C, because when the object is already reached B, it had some velocity, and that will be initial velocity for the next part of the journey, right? Okay, coming back to the third case, let's figure out this, our equation 1 here, and let's figure out our h2. So h2 will be equals to half g into 10 square, which is 100, okay, and minus h1. I'm taking this h1 on the other side, minus h1, and what's the value of h1? Half g 25. So I'm just taking half g common, and this will be 100 minus 25. What is 100 minus 25? 75. So it will be half g 75. This is our h2. I hope this is clear. Equation number 2. I hope this is clear. Let's figure out our h3. How do we find h3? Now again, there is the first option is either you find the initial velocity at point C. Okay, that will increase our workload. Better is find directly A to D. And what is A to D? And U is, in this case, U will be 0 and half g t square. What's the time? So 5 plus 5 plus 5, that's 15 square. I hope this is clear. Now what is h2? We already have 75g by 2. What's h1? 25g by 2. Let's do it here. h1 is 25g by 2. h2 75g by 2 plus h3, and that will be 225g by 2. 15 square is how much? 225. I hope this is clear. Now 75 plus 25, 100g by 2. plus h3 equals to 225 g by 2. Let's take it that side. H3 will be equals to 225 g by 2 minus 100 g by 2. So how do we subtract? Very simple. Let's call this g by 2 as an apple. 225 apple minus 100 apple. How much apples? Let me repeat again in case if you are getting confused. G by 2 I am assuming it as apples. So 225 apples minus 100 apples. That's how much? Sorry. How much it is? 5 125 g by 2. Now we got our h1, h2 and h3. I hope this is clear. How do you find h1, h2, h3? So it will be 125 g by 2, h3, h2 is 75 g by 2 and h1 is 25 g by 2, right? I hope this is clear. In case it is not clear, please go through the video once again. I am removing this part and I am finding the ratio. So let's find the ratio of h1, h2, h3. h1 is 25 g by 2. h2 is 75 g by 2 and h3 is 125 g by 2. Let's cancel out g by 2 from all of them. Okay, clear it is? Okay, but they are saying find the ratio of h1 is to h2 by 3, or we have to prove it like this, no? So let's prove it like this. We don't have to find the ratio in this way. Let's find the ratio. If you find the ratio, you will get that same thing, but let's find each one of them. Okay, so h1 is h2 by 3. So h1 is h2 by 3. Let's prove it. Okay, so what is our h2? This one. I am finding the ratio of h1 and h2. So h1 upon h2 on the left hand side, it will be how much? h1 upon h2. That is equals to how much? 25 g by 2 whole divided by 75 g by 2. Correct? G by 2 gets cancelled. h1 upon h2, that is equals to how much? 25 is to 75, 1 is to 3. So h1 is equals to h2 by 3. I hope this is clear. Let's divide h1 and h3. Okay, this part is clear. Let's divide h1 and h3. So I am just removing this part. Let's divide h1 and h3. So on dividing h1 and h3, h1 upon h3, h1 is how much? 25 g by 2 and h3 is how much? 125 g by 2. Let's cancel out g by 2 with g by 2. 25 5s are, so h2 upon h3 is equals to how much? 1 by 5. Cross multiplying, it will give us h2 is equals to h3 by 5. I hope this is clear. This is h3 by 5 and this is h2 by 3. So we can equate all of them and we get our B equation, desired equation. I hope this is clear, but better is to remember this. It will save your this much time, okay, in exams. So we already know, I have given you in the previous lecture. If you have watched that, okay, you are already familiar with this ratio 1 is to 3 is to 5 is to 7. Let's move to our next question. Great, we have another problem. It says the displacement x of a particle of mass m moving in one dimension under the action of a force is related by t equals to, so let me write here t, that is equals to root under x plus 3, right? Okay, the displacement of the particle when its velocity is 0. So first we have to find the velocity, put it equal to 0, find the value of time, put it back here, and that will be our result. So let's take this t3 on the other side, make it simple. This will be root x, right? Squaring both the sides, t minus 3 whole square, and that is our function for displacement, right? X is equals to t minus 3 whole square. Now what will be your dv by dt? Sorry, dx by dt. That will be your velocity, so that will be dx by dt. What is our x here? Let me substitute here. So it will be d by dt of, what is our x? T minus 3 whole square. Differentiating this, you will get 2 times t minus 3. And that will be your velocity function. If this is your velocity function, let's substitute this velocity function as 0. So this will be equals to 2 times t minus 3, and this will be 0 equals to t minus 3, and 3 seconds, that will be your time. So at t equal to 3 seconds, velocity is becoming 0. Question is asking, find the displacement of the particle when the velocity is 0. So displacement, where is our displacement function? Here it is. Let's substitute this value of t here only. So it will be 3 minus 3 whole square, that will be our x, and that is 0. So displacement of the particle is 0, option B. I hope this is clear. Clear it is? Displacement can be 0, right? We already know that. Let's see the next problem. Great. Our next question says a particle covers half of its total distance with speed v1 and the rest half distance with the speed v2. Its average speed during the complete journey. Direct question. You have to remember this. It's 2v1 v2 by v1 plus v2. We have already done 3 lectures based on total average speed. Okay, so that you can watch to figure out how we got this particular part, right? So I hope you can see that. I'll not solve this particular question, though it is a PYQ, but they have asked it directly, so I'm not solving this part. Let's see the next one. Okay, great. Let's see the next question. The next question is a boy standing at the top of a tower 20-meter high. So let's say this is our 20-meter high top, a person standing here. This is our 20-meter high tower. Okay, fine. Drops a stone. So when something is dropped, if something is dropped, what does it mean? It simply means initial velocity is 0. Okay, fine. Assuming g is equals to 10 meter per second square, fine. The velocity with which it hits the ground. Now, there are two ways. First, I will tell you how we got this, and then we have to remember the direct formula. In case if you know the direct formula, fine it is. Otherwise, just remember this equation: v square minus u square equals to 2as, right? In case our initial velocity is 0, when something is freely falling or something is simply dropped, v square will be equals to 2as, right? And acceleration due to gravity when something is falling down is gs. Okay, so v will be equals to under root 2gs or 2gh, height of this tower or the building, right? So you have to remember this particular relation directly to solve such problems, correct? What is this v? This is the velocity just before it hits the ground. So let's figure out this velocity. Now onwards you have to remember this. I will not solve it again. Okay, so let's solve this. V square, v will be equals to final velocity, that is root under 2gh. Let me substitute. What is the acceleration due to gravity here? 10. And what's the height of the tower from which it is falling? 20. So this will give us 20 meter per second. Let's see if there is any option. Simple problem. Yes, option A is correct. 20 meter per second. It will be the velocity with which this particular stone or the object, stone, will hit the ground. Let's see the next question. Okay. Let's see our next problem. Our next question says a ball is dropped from high-rise platform at t equal to 0 starting from rest. Fine. So initial velocity of the ball is 0. After 6 seconds, another ball is drawn. Okay. Thrown, not falling down. It's thrown downward from the same platform with speed v. Okay. The two balls meet at t equals to 18 seconds. What is the value of v? Okay, let me explain you the scenario first. Okay, let's say this is the tower, and from this tower we are initially releasing first ball. Now for the first ball the initial velocity is 0. Clear? Second ball I am throwing it downward. When I am throwing it downward it will go rapidly, and both of them are meeting at t equals to 18 seconds. Clear? Now this is a thought experiment. You have to think a little bit, right? A little bit when I'll tell you where to think. Right now, what we have to find, where we have to focus, the velocity v. Okay, so let's draw this. Let's say this is the building or the tower, and from here, first ball is going down, right? Now, if it is going down, initial velocity is 0. Let's say this is the point it reached at any point A. Okay, from starting point to any point A, the first ball reaches. Okay, and another ball that also reaches at point A. They both reach at point A, but the first one was initially dropped and the second one was thrown after 6 seconds. Be very careful. So while going from, let's say this is point B, while going from A to B, first ball will take how many seconds? What is the time period for the first one while going from here to here? Say 18 seconds, right? 18 seconds. But the second ball was dropped after 6 seconds. So the second ball is taking how much time to travel this distance? The same distance. Lesser time. Why lesser time? Because it has already some initial velocity. And what will be the lesser time? 12 seconds. Why 12? Because 18 seconds it is taking the first one and the second one is taking 6 seconds less. Let me repeat again in case if you are getting confused a little bit. Let me repeat it for the last time. Okay, so let's do it fast. We have a person standing on this particular building and he has two balls in his hand. Okay, the first ball he released, simply dropped it. When he simply dropped it, it is going with certain initial velocity is 0, so certain velocity it will acquire at moment it reaches at point A, and that it travels from here to here in 18 seconds. Which one? The first ball. Okay, now another ball I have in my hand and I'm not releasing it, I'm throwing it downward. When I'm throwing it downward, it already has certain velocity when it was thrown. So moment it reaches at point A, it is taking lesser time to reach this point. And what is that lesser time? Because it was released after 6 seconds. So it is taking how much? 12 seconds, right? Okay, fine. So I'm saying that to go from A to B, the first ball, S is equals to ut plus half at square. Correct? And what is S? The distance traveled from A to B. I'm just writing here AB. Initial velocity for the first ball, 0. Why 0? It simply dropped. Okay, half. What is acceleration due to gravity? 10. And what is the time taken by the first ball? 18 square. Correct? This is our equation number 1. Now the second ball was thrown after 6 seconds. So it is taking less time to reach at the same point. Sir, why same point? Why the distance is same? Because if the distance will not be the same, how they are meeting? They are meeting, which means you are reaching at the same distance, same point, same position, right? So they both are reaching at point A at the same distance, same position, but the time is different. Why time is different? I hope I have already explained you. So AB will be equals to, what is our U in this case? So in this case, the ball is thrown with the velocity v, so it has initial velocity vt. And what's the time now? The time now will be 12 seconds plus half g, which is 10, and into 12 square. I hope this is clear. Let me repeat again how we got this equation. S equals to u, which is v. As per the question, it is thrown with an initial velocity v. Time 6 seconds after 6 seconds, so it's 12. If that is taking 18 seconds to reach here, this person is taking only 12. Assume it like a person. Okay, 12 half g t square. I hope this is clear. Now let's equate both the equation 1 and equation 2, because this is also AB and that is also AB. Let's equate both of them. So I am writing here half 10 18 square will be equals to 12v plus half 10 12 square. Let's solve this and find the value of unknown, which is v. I'm taking this whole thing on the left hand side. So let's make it as 5 into 18 square, which is 324, minus 5 into 12 square, which is 144. That is equals to 12v. Correct? Now let's take 5 common. It will be 324 minus 144 equals to 12v. And that will be 5 into 4 minus 4, 0, 12 minus 4, 8. Okay. 2 minus 1, 180, whole divided by 12, that will be equals to v. Correct? Let's cancel out 6 2s, 6 30s, and 2 15s. 15 5s, 75. Approximately 75 meter per second. That is option. Let's see which one. Yeah, approximately we can say. I think this is mistyped one. Okay, this is 75 meter per second. Option A is approximately correct. I hope this is clear. Right? In case if you have not understood, please go through it once again and you will understand it. Let's see the next one. Great. Our next question says a particle starts its motion from rest. So initial velocity is 0, u is 0. Under the action of a constant force. Now be very careful, constant force, which means what will be the constant? Acceleration here, because we are dealing with kinematics and not laws of motion. So here the acceleration will be constant. We'll keep it fixed. If the distance covered in the first 10 seconds is S1, and that covered in the first 20 seconds, T1 is this and T2 is 20 seconds, is S2. Fine. Then which of the relation is true, right? So let's solve it using the same equation. S equals to ut plus half at square. And for the first case, S will be equals to S1, u is 0, half a, and time is how much? Time is 10 seconds, so it will be 100, right? Second case, u is again 0, S2 will be equals to half A, and instead of T is what, 20 this time, so it will be 400, right? Let's divide both the equations, S1 and S2. So dividing both S1 upon S2, half cancels with half, right? A cancels with A, 100 upon 400, that's 1 by 4. Let's cross multiply, we will get 4S1 is equals to S2. Let's see if there is any such a relation. Yes, option C is correct. S2 is equals to 4S1. I hope this is clear. Clear? Let's see our next problem. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance of 135 meter in t seconds. Find the value of t. Direct straightforward question based on the equations. Okay. So initial velocity u is 10 meter per second. Final velocity is 20 meter per second. Distance is 135 and time is t seconds, right? We have to find the value of t. Okay, so we know that we can use the equation v square minus u square equal to 2as. This will give me a. Once we get the value of a, now we can use v minus u equals to at. I hope this is clear, right? Now we will make use of these both equations. Let's figure out one way in which we can solve one particular equation by substituting this here, and we can find it, right? So I'm just removing this whole thing, and I'm just writing it here so that you can compare it. V minus u equals to at. Let's substitute the value of a here. So the equation will take the form v square minus u square equal to 2s into a. A is how much? V minus u by t. And let's take t that side. So t will be equals to 2s into v minus u upon v square minus u square, right? And what is a square minus b square? A square minus b square is a plus b into a minus b. So t will be equals to 2s into v minus u upon v minus u into v plus u, correct? Let's cancel out this with this. We left with t, that is equals to 2s upon v plus u. Now what is s? Sir, s is nothing but 135. And what is v plus u? V plus u is how much? 10 plus 20, 30. Let's simplify it. So 5 6 and 5 2s 10, 27, 3 2s and 3 9s, 2 cancels out. We got 9 seconds. Is there a, yes, time is 9 seconds. That's our correct answer. I hope you understood this question. Let's see the next one. Okay. Our next question says the distance traveled by a particle starting from rest. So u is equals to 0. Moving with an acceleration a is equals to 4 by 3 meter per second square. In the third second is how much? So to figure out, we will make use of our nth formula. Okay, Sn, that will be how much? U plus a by 2 into 2n minus 1. I hope you are familiar with this relation, right? Now I will not derive this relation right now. We have to directly remember this part. Okay, you can derive this equation from our equation as equal to ut plus half at square and find for nth second. Okay, Sn will be equals to un is 0, u is 0, so that will be equals to a, which is 4 by 3 whole divided by 2, and in which second we have to find? Third second. So n value is 3 minus 1, right? So it will be 4 by 6 into 6 minus 1. So this will be, or we can simplify it, 2 by 3 into 5. That's our 10 by 3. Is there such option 10 by 3? Yeah, option C is correct, which is 10 by 3. I hope this is clear, right? Let's see the next one. Two bodies, A has a mass of 1 kg and B of mass 3 kg. Great. Are dropped from heights 16 meter. So H1 is 16 meter and H2 is equals to 25 meter. Fine. The ratio of time taken by them to reach the ground. Okay, let me just modify this problem and explain you one important concept. If both were released from the same height, they will reach the ground at the same time. Okay, be very careful with this regardless of what is the mass. Okay, but in this case, in this particular case, both are released from different heights. Just assume that you are standing on 5th floor and your friend is standing on 30th floor. You both are releasing at the same time two different objects. Okay, both of them will reach the ground at different interval. Why? Because height is different, right? So if height is different, Why it is so? Let's look at the equation. S equals to ut plus half at square. Initial velocity, you are dropping them. If you are dropping, u is 0. If you are dropping anything, u is 0, initial velocity is 0. So S will be equals to half at square. For the first case, H1 will be equals to half g t1 square, and H2 is equals to half g t2 square. From these two equations, we are clearly seeing that A and B, 1 kg and 3 kg doesn't matter. Mass doesn't matter. So if you are releasing something from the same height, the time taken is same, regardless of what is the mass. But here in this particular case, the height is different, so the time periods will be different. So let's figure out H1 upon H2. Half g cancels, T1 square upon T2 square, right? Let's substitute the values, okay? So T1 upon T2, that will give me straight away root under H1 upon H2. And T1 upon T2, that will give me under root, what is the value of H1? What is the first height? 16. And H2, 25. So this will give me T1 upon T2 as 4 by 5. Correct? So 4:5, that's the ratio of time period. Okay.